Hi everyone, in this video we will be studying how to solve absolute value equations. Right. So first of all, what is absolute value? Absolute value makes numbers either 0 or positive, so the answers can never be negative. Okay, so for the first one, and first of all, the absolute value bars are just these straight lines around the 4. Okay, so absolute value of 4 is 4. Because it's already positive, so it stays positive. Absolute value of negative 4 is 4, because it becomes positive, and absolute value of negative 2 is 2. So sometimes we can understand absolute value as a distance, because distances are either 0 or positive. Distances are not negatives. In math, to solve always means to find every number that makes a number sentence true. So for this particular case, absolute value of x equals 6. So x could equal 6, because the absolute value of 6 equals 6. But x could also equal negative 6, because if you were to plug negative 6 in for x, then negative 6 absolute value would be 6. So the key idea is that there's two answers to every absolute value equation. Okay, so here, absolute value of x equals negative 4. Okay, so surprisingly, there's no number that makes this true, so there's no solution. Because if we think about it, if we try x equals 4, and you plug the 4 in, then absolute value of 4 is 4. It's not negative 4. Or if you try x equals negative 4, and you plug that in, then absolute value of negative 4 is 4. So since absolute value here represents a distance, it's impossible for that distance to be a negative. So the sheer fact that there's a negative right here means that this equation automatically is no solution. For this one, we're not allowed to just simply plus 3 plus 3. That's the common mistake, and it's because these bars get in the way and don't let us to add 3. So taking a look at another problem right here, so everyone knows that we cannot just simply add 3, and we can't just add 3, because this 4 gets in the way. So if this 4 gets in the way and doesn't let us to add 3, then for the same reason, these bars get in the way and we cannot add 3. So instead, if we just try to figure this out by guess and check and just guess numbers for x, such that this would make it true, then we can guess that x has got to be 5, because you plug 5 in, and 5 minus 3 is 2, so that makes it true. Then we can also kind of guess that 1 would make it true, because you plug 1 in, and thinking ahead a step, 1 minus 3 is negative 2, then absolute value of negative 2 equals 2. So it turns out that the answers to this equation are 5 and 1. But we don't want to solve every problem by guess and check, so there's got to be a better way. So a key to these problems is to write two separate equations. And the two separate equations we can write would be x minus 3 equals 2, and x minus 3 equals negative 2. And what's surprising about this is that we're not changing that minus. It's not x plus 3 equals 2. Instead, we're changing this answer right here, the answer of 2 for our two cases, 2 and negative 2. And then the thing in the absolute value bar is x minus 3 stays exactly the same. I call this undoing the absolute value bars, and you have two cases, x minus 3 equals 2, and x minus 3 equals negative 2. So now, just two simple equations, if you go to solve those, Then I'm going to add 3, so x equals 5, and add 3, so x equals 1. So the answers to this problem are x equals 5 and x equals 1. So in this one, let's write two separate equations. 2x plus 5 equals 3, and 2x plus 5 equals negative 3. So 2x plus 5 equals 3, and 2x plus 5 equals negative 3. So let's solve these problems individually. So minus 5, 2x equals negative 2, divide by 2, x equals negative 1. The other one, minus 5, draw your line, bring down the equals, 2x equals negative 3 minus 5 is negative 8, divide by 2, so x equals negative 4. So the answers to this one are either x equals negative 1 or x equals negative 4. You can check by guess and check, or you can check by plugging it back in that it makes it true. Negative 2 plus 3 is 3, absolute valued, which equals 3, or negative 8 plus 5 is negative 3, absolute valued is 3. In this one, I'm just going to write it so that the absolute value comes first. So it's exactly the same as it was. Next, I'm going to write two equations. And the pattern is 2 minus 3x equals 40, and 2 minus 3x equals negative 40. So writing it. So now I just have two easy equations to solve. So solving the first one, minus 2, negative 3x equals 38. So divide by negative 3, x equals negative 12.7. So that's one answer. Other one, minus 2, negative 3x equals negative 42. Divide by negative 3, x equals 14. So the answers to this question are both negative 12.7 and 14. If you only had one of the answers, then it would not be correct, because to solve means to find both of the answers. This one looks a little bit more complicated, but a first step would be to get the bars alone. So in order to get the absolute value bars alone, we want to get this red section alone by itself. We want to isolate that. So first, we have to undo this plus 3 and this 2 that are on the same side. Okay, now these bars are not parentheses, so we're not going to do it by distributing. And for this case, you could, but if it were a negative, then it would throw it off. So going through a different procedure, what we want to simply do is minus 3 to both sides, and then divide by 2 to both sides. So pretending that that whole red thing is just a variable in itself and just getting it by itself. So starting off by minus 3 to both sides. Draw your line, the 3's cancel, so bringing down to absolute value of x minus 4 equals 7 minus 3 is 4. And then if I divide by 2, x minus 4 equals 2. Now that the bars are by itself, we can solve this problem just like any other absolute value. So writing two equations, x minus 4 equals 2, x minus 4 equals negative 2. Okay, so now just add 4, x equals 6, add 4, x equals 2. So the answers to this equation are 6 and 2. We can see that's true if you plug 6 in here. If you plug 6 in, 6 minus 4 is 2, then 2 times 2 is 4, and 4 plus 3 is 7. Plugging in 2, 2 minus 4 is negative 2 times 2 is negative 4. No, I'm sorry. 2 minus 4 is negative 2, but then absolute value is 2. So 2 times 2 is 4, plus 3 is 7. Last one, first step would get the bars by itself right there. Okay, so getting those bars by itself, we'll first add 1 to both sides, and then we'll divide by 4 to both sides. So adding 1, cancels 4, absolute value of x is 12. Divide by 4, absolute value of x is 3. So undoing the bars, we'll get two cases, x equals 3 and x equals negative 3. See you in class tomorrow.